Hello everyone. So today we are solving a question of JEE Advanced 2020 from the topic of thermodynamics. So let's first read the question, and it says that let's consider 1 mole of helium gas enclosed within a container with an initial pressure and volume P1 and V1, which expands first isothermally and then it expands adiabatically, and its volume becomes from 4V to 32V1. So the work done by the gas during the isothermal are W-ISO and W-AD. Okay, so it's a very much formula based question, and you must remember some concepts like for isothermal work, we write it as nRT, which is the constant temperature ln of V2 by V1, or nRT ln of P1 by P2. So these two concept formula can be used for the isothermal work done, and for work done through adiabatic, we write it as P1 V1 minus P2 V2 by gamma minus 1, where there is also a relation, that is PV gamma is equal to constant. We can write it as K. Okay. So if you want to know from where this comes, you can derive it from the adiabatic equations. And if you let me write for, if we write any process of formula PVX, we can represent it as like this, except for x equal to 1, PVX equal to constant K. So you can note it down also, like it will be very much helpful to solve almost all kind of work done. You can solve it except for K equal to 1, that is the isothermal. We have different formula. Okay. So let's proceed to the question. Let me erase all this. So here given first, the volume changes from V1 to 4V1. So what can be the work done here? It will be nothing but 1 mole is given. So RT ln of 4V1 by V1. So it will be equal to 2RT ln 2. This is the work done for the isothermal part. And now if we want to calculate for work done in adiabatic, so we know that PV gamma is equal to constant for adiabatic processes. So if initially it was like we have to draw, let me show you. If this is the PV diagram here, P and V. So initially what happens at the constant temperature, P and V are decreasing like this. So from if okay, let me draw it like this. So if this was V1, so it becomes 4V1. Like I should make it more steeper, but let's consider it like not up to the mark. So from 4V1, it goes to 32V1. Okay. So now what happens here, as volume is increasing, pressure should definitely decrease here. So PV gamma equal to constant will be mentioned. So we have to solve work done for this part. So how can we solve initial? Let me write. Okay. At this point, what is the pressure here? Because from this path, it came from isothermal. So PV is equal to constant should be maintained. So if V become 4V, so P should become P by 4. So at this point, what is P is, it is equal to P1 by 4, and the V is 4V1. 4V1 to the power, what is gamma? As helium gas is nothing but it's a monoatomic gas. So for this, we know that gamma is equal to 5 by 3. Okay. So putting gamma equal to 5 by 3, this should be equal to, at that point, what will be the pressure? We have to find P2, and given volume is 32V1 to the power 5 by 3. So if we do all kind of calculations, so we will get as P1 by P2 is equal to, if we take 32 there, 8 to power 32 into 4. P1 by P2 is equal to 32 into 4, that is 128. So P2 technically becomes P1 by 128. Okay, now we have to calculate for the work done. So P1 V1 minus P2 V2 by gamma minus 1. So what we can do here is P1 V1 minus, what is P2 here? It is nothing but P1 by 128. Final volume is 32 times V1 by, what is gamma minus 1? It is 5 by 3 minus 1. So I want to calculate it in the same place only. Just select all this. I hope it will be fine now. Yeah, if so doing this, we can get P1 V1 We know that P1 V1 equal to, like I should write all this before, P1 equal to RT, because it's given 1 mole only. So writing P1 V1 as RT, so RT 1 minus 32 by 28 is nothing but 4, 1 minus 1 by 4, and 5 by 3 minus 1 is 2 by 3. So what we will get is 4, 3 will go there. So RT 9 by 8. Okay. So hence what we get, it was 2 RTLN2 and it became 9 by 8 RT. So ISO by this will be equal to 16 by 9. That is 1 point for 6377, something like that. This should be the answer. Thank you, everyone.